All right, so in number 2, the first thing I want to do is I want to get I want to represent the compass with a circle. All right, so that's going to be the compass. Good thing about a compass also is we can reference the direction in terms of north, south, east, and west. So here is the compass, and it says a charge of +4 microcoulombs is fixed at the center of the compass, and they give us the radius of the compass. So I know how far away the charges are going to be away from the center. So a charge of plus is in the middle. So I'm just going to put right now, I'm just going to put a plus. I'm not going to label it at this time. I'm just saying that that's plus there. 2 charges are fixed on the circle. The charges are plus 3.5 microcoulombs at the position due south. So I have another plus one down here. And I have a negative one at the position due west. So I have a negative one right there. Now it says I could figure out what the charge is on this one caused by those two, or I could figure out what the I could figure out either the force on this one or the electric field at this location based on those two, or I could figure out the force on this one or the electric field at this location based on those two, or I could figure out the force on this one or the electric field at this position due to those two charges. So in this problem, it's what's the magnitude of the net electrostatic force acting on the charge at the center. So that this is my test charge. These two are source charges because these two are creating forces at that point on this charge. So based on the one that's to the west, will that be will the arrow be to the left or to the right based on the charge that's to the left of the middle? To the right? Now remember, like charges repel and unlike charges attract. So yeah, so these two right here are opposite charges. So they're going to be attracted to each other. So whatever force is on this one is going to be in this direction. All right, so that's the direction of the force on that one. Now, what about the direction of the force due to the charge that's at a position south? What direction? Up. So I'm going to have another one in that direction. Now, since I'm putting the charges, since I'm putting the forces on the one at the middle, I guess what I will do, I need to number. Well, I need to label these charges. So I'm going to call this one right here. I'll call that QC for the charge that's at the center. And I will call this one down here QS for the charge that's south. And I'll call this one over here what? What? QW, because that's the one to the west. Now, again, you don't have to use those. You can call them 1, 2, and 3 if you want. You could also maybe call the one at the middle, since that's really the test charge, you could call that QO and then call these 1 and 2 as the two charges that are creating a force on the test charge. So now that we have that, the next thing we're going to do, we do know the radius of the circle here. Let's see, where's a good place to put that? I guess I'll write it here. The radius is 0.25. So the next thing, once you have the picture, and you need to do a picture for these problems, once I have that, I want to now figure out each of these two forces. So I am going to call this force right here, since it happens to be going north, I'm going to call it the force north. That's one of the two components of my net force at the center. So I'm going to call that, I'm going to say Fn is going to equal the K and the two Q's that create that force. Now, can you fill this whole thing out? So since I'm solving for the one north, then I know that the two charges involved are going to be this one and this one. So as far as instead of Q and QO, I'm going to call this QS and QC over R squared. So that's going to be, so using Coulomb's law, I'll be able to get that particular force. So plugging in the numbers, and we're going to have K, the two Q's, over R squared. So the K is Coulomb's constant, 9 times 10 to the 9th, Newton meters squared per Coulomb squared. And let's see, the charge south, I have to look at the picture here. The charges are plus 3.5 microcoulombs at the position due south. So this is the one that is due south. 101. So this is, what? Oh, I don't know. What his name? All right, so that's going to be 3.5 times 10 to the negative 6 coulombs. Does anyone know where he is? S? All right, now I'm not putting in the charge, the plus or the minus here, because I already put the direction on the picture. Right, so the picture already has, because these two are both positive, I know it's up, so I'm not going to put in, even if this was negative, I'm not going to put it in here. I just want the value. I want the magnitude of each one of these. So that's QS, and then QC is the one in the middle, and the one in the middle is this one. So I'm going to write that as 4.0 times 10 to the negative 6 coulombs, and the R is 0.25 meters. All right, so if you solve that, what do you get for that answer? Again, this was a homework problem, so somebody should be able to give me an answer to this problem. Yes. 2.02 newtons? Okay. So 2.02 newtons, that's the force north. The other one happens to be going west, so I'm going to call that the force west. So and again, the points would be, you'd get some points for the picture, you'd get some points for solving for the individual forces, but ultimately, you're going to want to solve for the net force, which means I am going to be adding up these two forces at the end. So the force west is going to be K, two Q's. Now one of the Q's is the one Q west, Q south, I'm sorry, not Q south, Q center over R squared. So K, the two Q's over R squared. So the K is 9 times 10 to the 9th Newton meters squared per Coulomb squared. And again, the charges, I already dealt with the charge on the picture. That's why the arrows are in the direction that they're in. So I just need to have their values. So Q west, it has negative 6 microcoulombs. I'm just going to put it in as 6. 6 times 10 to the negative 6 coulombs. So don't forget, all of these ones that are in microcoulombs, when you write them in coulombs, you have to multiply them by 10 to the negative 6 to get them in the right units. And then the other one is the center, so that's still going to be 4.0 times 10 to the negative 6 coulombs, and the R is 0.25 meters. So what do you get for that answer? What is it? 3.46. All right, so now that we know those two, we can add these tip to tail. So, and that will get me the resultant. So I can either move this vector to the end of that, and this would be my resultant, or I can move this one to the end of that, and it's still going to be the same thing. So it doesn't matter which one you add to which. This is going to be now my resultant. Usually we use F subscript R for the resultant. When you're combining vectors, usually the letter R is what's used. And I want to check one thing up here. It says, oh, it just is asking for the magnitude. It's not asking for the direction. If they had said, what's the net electrostatic force, and not just the magnitude, I would also be solving for the direction. So I'd have to use, get the angle involved in the problem. So solving just for the magnitude, I'm going to have, well, let's look at the picture again. I'm going to have I'll do it this way. So I have, that's going to be my north, and on the end of that, I'm going to put the west. So this represents the force in the north direction, and this one represents the force in the west direction. So my resultant is going to be this. So this, what I just drew, that is my resultant force. Now, if they asked me for more than the magnitude, then the angle, I would get this angle right there. And the angle would be so many degrees west of north. Now, if I had used the angle down here, if I had first drawn this arrow and then drawn the north one, then I would have had this angle, and then that would have been north of west. So you're either west of north or you're north of west for direction. But again, this problem only asked for magnitude, so I just have to use the Pythagorean theorem to get the magnitude. So FR is going to equal the square root of Fn squared plus Fw squared. And then plug in the numbers and you'll have the answer. So for the north, that was 2.02 newtons. And the west was 3.46 newtons. Square both of those. And you get for the answer 4.01. 4.01. And that's all they asked for. But again, if I was solving for the full vector, I would want the direction because the force is a vector, so I would want the magnitude and the direction. They only asked me for the magnitude in this problem, so that's all I bothered to solve for. Any questions on this one?